Hey everyone, today we are going to solve the LeetCode question maximum number of balloons. Okay, let me explain with this example. Text is A, B, O, L, L, A, blah, 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 and this is balloon. So to determine how many times we can form the word balloon from the character in text, we need to count the frequency of each character in text. So let's say when we count each character, so we will get like this. So let's say count, and this is hash map, and B is 5, and let's say A is 5, L is 6, and O is 4, and N is 5, like this. And we also need to count how many times each character is required to form the word balloon. So let's say balloon hash map, and B is 1, A is 1, L is 2, and O is 2, and N is 1, like this. At this point, we have two hash maps, one containing the character count from text, and another containing the character count required for balloon. We iterate through balloon hash map and divide the count of each character in text by the number of times that character is needed in balloon. Why do we need to divide? The reason is very simple. We are calculating how many complete copy of balloon each character can contribute to. So for example, if there are 5 B character in text, so then B could potentially support 5 copy of balloon because only one B is needed per word, right? So B needs like 5. So how about A? So we need one A, but the count has 5A, right? So potentially A support 5 copy of balloon, right? So 5. And how about L? So we need 2L, and count hash map has 6L, right? So potentially 3 copies, right? So 3. And how about O? So we need 2O to create a balloon, and count hash map has 4. So that's why 4 divided 2 is 2, right? And how about N? So we need 1N to create a balloon, and count hash map has 5N. So that means potentially 5 copies, right? So 5. Now here is a question. How many times can we actually form balloon? The answer is 2. Why? Because a word only counts if we can form entire word. The number of complete balloons we can make is limited by the character that runs out first. In this example, O can only support 2 copies of balloon, which means we cannot create more than 2 complete words, right? Regardless of how many of the other character we have. That's why we divide the count and then take the minimum value. The smallest result represents the maximum number of complete balloons that can be formed. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, let's write the code. First of all, create a count hash map. And then for character in text, and count and the character equal 1 plus count dot get, and C and the default value is 0, like this. And we do the same thing for balloon. So balloon, so this is hash map. For C in balloon, and then balloon and C equal 1 plus balloon dot get, and C and the default value is 0. And after that, create a like return value. So let's say min num, and do not set 0 because there is a possibility that minimum number is not 0. So I put like length of text here, and then for character in balloon. And then if character not in count, so in the case, just return 0. And then if not the case, min num equal min and current min num versus count character divide balloon character. After that, return min num. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n. So n is the length of input text. And memory space complexity is, this is actually O1. So somebody wondering why. So because we use hash map, so this could be like an order of n. So that's because constraint said text consists of lowercase English letter only. So that means worst case scenario of space complexity is order of 26, right? Which is O1. Okay, let's do the coding exercise. And in the solution 1, we use 2 hash maps, but actually we don't need to use hash map. So let's delete everything. And instead of hash map, we use simple variables. Let's say b equal a equal l equal o equal n, and initialized with 0. So this is a count of each character in text. So let's iterate through one by one. So for character in text, and if character equal b, in the case b plus equal 1, else if character equal a, in the case a plus equal 1, else if c equal l, in the case l should be like a plus 1, and then else if character equal o, in the case o plus equal 1, else if c equal n, in the case n plus equal 1. And then after that, so this is the same idea from solution 1. So we take like a minimum number, so return min and b a and l, but we need 2l, right, to create a balloon. So that's why divide 2, and o also we need a 2o, right? So that's why divide 2 and n, and we take a minimum value. Yeah, so that's it. So let me submit it. Yeah, looks good. And time complexity and the space complexity are same as solution 1. So time is On, and the space is, I think, O1. Yeah, so that's all I have for you today. Please support me with actions such as comment and hitting like button. I'll see you in the next question.